Alright, Phil. Talk about science.
Right, what are we going to talk about?
What are solar waves?
Solar wave, solar wind.
Solar
Right, solar wind, right? You got the sun, and it's emitting like shitloads of radiation, right?
Yeah.
And the solar wind is basically what scientists call solar radiation, so it's like a wind, right? And then the reason why like the atmosphere doesn't come off the planet, like, because you can imagine like if you've got a rock with like, say like a low layer of water over it or whatever, and you've got wind, it's going to blow the atmosphere off. So the planet has got a magnetic field, right? Like, around it, created by the spinning iron core in the planet, in the middle of the Earth, right? And that sort of repels the magnetic wind, so that's why the atmosphere doesn't blow off the planet.
Does the magnetic field have anything to do with gravity?
No, has nothing to do with gravity. Gravity is like completely different kettle of fish.
It's not like the magnetic field is like preventing me from like jumping higher than that.
No, that's gravity. It's like two different forces, man.
Alright, so what's your, you know that solar winds are my favorite topic. Well, what's your favorite topic?
Do you know where like static from TVs comes from?
No.
You know when you're tuning in a TV or a radio for that matter, you get like shh or like white dots. Yeah, that is the aftermath of the Big Bang. It's like residual radiation. Right.
How do you know this? How does one know this?
All right. The European Space Agency, right, have just put a satellite in space. There's the mapped background microwave radiation, right?
Yeah.
And it can see like a whole spectrum of the night sky in a different wavelength, yeah. And that has shown the different variances in gravity, which proves, right, like after the Big Bang, like I haven't got the numbers like right, but like say like a trillionth of a second after the Big Bang, all there was like a primordial soup of like quarks and shit that make up nucleuses. Yeah, I probably should go into a bit more detail. Right, hold on. So, starting a Big Bang, right? You've got something that is infinitely small and infinitely dense, right? And for some reason, like, that physicists don't know because it's like the Big Bang, it's quite hard to work out, that the universe expanded faster than the speed of light, right? And all that was there, like a couple of trillionths of a second after the Big Bang, was just a mass of plasma energy made up of all the fundamental things that make atoms, right? But for some reason, which they just discovered a particle called the Higgs boson in the Large Hadron Collider, yeah. For some reason, this particle like gave mass to like certain parts of this primordial soup, right? So it wasn't uniform. It like there was bits of gravity, right? So when the universe like expanded like half a second after the Big Bang, it became like a mind-blowingly large, right? These points of gravity in space like started to slowly clump together, and when they clumped together, like the quarks became particles, like and atoms. So it would mostly have been hydrogen, because hydrogen is like the most simple atom, right? And then as the universe, wait a minute. What was I talking about? Background radiation. Yeah. European Space Agency mapped the microwave background radiation, and that shows the gravity variations in the primordial soup from like a trillionth of a second from when the Big Bang happened.
Okay. What is relativity?
What is relativity? I can't remember exactly. What? General theory of relativity.
How do you know?
Like,
How do you know all this primordial soup shit, and you don't know what relativity is?
I've got another one for you. Like, So,
Wait, how do you not know what relativity is?
oh, I do, but I'm a bit drunk, so I can't explain it properly. But, like, do you know where all the different elements come from in the world,
No.
in the universe?
No.
Right. So, you take the sun for example. The sun works by turning hydrogen into helium. Yeah. And that's what, when you fuse atoms together, they create a shitload of energy. Right. It's the same as splitting atoms. It creates a shitload of energy. That's what a nuclear bomb is, right? So the sun can fuse hydrogen into helium. And if you think about the sun, it's fucking big and it's got shitloads of gravity, right? So it can only fuse like the simplest particles together, hydrogen turning it into helium. So like one neutron adding to two neutrons to turn it into helium, right? But where do all the heavy elements come from? Like where's your plutonium come from? And all like iron and all the metals, like if they can't be created in this ridiculous furnace, like where do they come from? They come from stars exploding, right, in supernova, right? And when a star goes supernova, like it collapses under its own weight, right? The gravity is so strong, and only in those conditions can you create all the other elements in like the known universe, like everything, like even carbon that makes up what we're made of, right? So that therefore, like everything we know was born in one of these ridiculous explosions. And, like, all
Supernova.
Supernova, yeah. So we're all made of like explosions of stars.
We're all made of
Pretty
explosions of stars.
It's pretty cool, man. Because these
So-
elements like get made in when the star explodes and then it gets flung out into the universe, right? And this has happened like billions and billions and billions of time over the life of the universe, which is like fucking trillions of years old or whatever.
So last night, Alyssa was saying that we didn't land on the moon. I don't know if we landed on the moon, but why don't we have a moon colony yet? It'd be sweet to live on the moon for like a year.
There's like loads of fucking physical reasons why I can't live on the moon. One's like solar radiation and the lack of gravity on the human body. So like if you've got lack of gravity, like humans haven't evolved to live in low gravity. So like you're like growing, bones will grow weird and like you'll just get all fucked up basically. It's like the bends when you come out of the water. Like hydrogen out there. It's a hydrogen. It gets in your bloodstream. The bubbles that come in your bloodstream when you go.
You're the one that's supposed to know this.
Oh, come on, man.
Okay.
And there's like solar radiation from the solar wind because the moon hasn't got magnetic field, so it can't protect you from harmful
Yes.
radiation.
The old magnetic field.
Magnetic field comes into
Solar winds loves to take advantage of things that don't have magnetic fields. Okay. And what was the thing you were saying at Bogus the other night about the possibility for the world to get a lot brighter very soon?
Oh yeah, like the nearest star to us is called Betelgeuse or Alpha Centauri, right? And it is a red giant, right? So it's like something like 20 times the size of our sun. It's fucking huge. If like Betelgeuse was where our sun is, it would have gone past. So wait a minute, you've got Mercury, Venus, Earth, Mars. It would go up to Jupiter basically, so it's fucking big, right? And when stars are that big, when they collapse, they go supernova, right? So when this supernova happens and it's like way overdue, it could happen like any time now, or it can happen in the next 10,000 years. We don't know, but it's well overdue, right? When it explodes, it'll be like 2 fucking suns, man. Like in the night sky, can you imagine like 2 fucking suns? Like at night it would be like daylight, and in the daylight you'd be able to see 2 suns, and it would last like 2 months.
I think
That's science hour.
Science Hour with Phil Richardson.